Hello. Problem 3. H and T for each cusp. So what are the cusps? As far as I remembered, it was 1/2, naught and infinity. But I just looked up the work I did. That was in chapter 3. And here we see the cusps is -1/2, naught and infinity, of course. But 1/2 is equivalent to -1/2 by t. And then I got a little shock with the symbol j of t point z, because what is the symbol naught over naught on 1? My intuition said naught, but I looked it up in the chapter and it's actually 1, so everything's okay there. We start with the cusp at infinity. Oh, that's blue. And t itself lies in gamma naught of 4, so that means h is 1, and then t, that was actually exactly why I wanted to find j of t point z, naught over 1, epsilon 1. Oh, t is the coefficient, so never mind. Square root 1. Unity, 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 so that's 1. I'm actually a little uncertain, but this must be so in any case. Now, if we take the cusp at naught, then infinity is s of naught. And there we have to take an arbitrary matrix and then operate with S and S inverse, which is minus S CD minus A minus B minus minus D and B. Now what I'm going to do, that was the first row, and then the second row is just C minus A. And that needs to lie in gamma naught of 4. And of course it needs to have the form 1 h naught 1. This is naught. AB is 1, B is naught, and C, that must be naught or 4, that must be a multiplum of 4, so that means the generators are plus minus 1, 1, 4, naught. I'm overcomplicating it here. B is a multiple of 4, so it's naught 4, and that means h equals 4, and that was actually what I already has found as the ramification index. I think they are the same. And then T, let's do J set, J of one, 4, so it's still naught on 1, epsilon 1 times the square root of 1, so that gives unity. And if it's minus, by the way, then we would get minus minus minus, or whatever, minus, and then the symbol will give 1, but epsilon minus 1 is I, the imaginary unit, so I have to check that. Well, the one requiring most work will be 1 minus 1/2. So the matrix, it's called gamma because we need to have it in, that maps minus 1/2 to infinity. I think minus 1/2 times 2 gives minus 1 plus 1 gives naught. So something divided by naught, good, which has determinant unity. And that means the inverse should be easy. I think you can just see what I'm writing here. Before going on, I'd like to check that these equations are correct. And then I will also check that this value I find here actually is t, because I didn't clearly get that from the text while studying it. I thought I'll have to look at that later, and that has become now. I have had my lunch now, and it's soon time for coffee, but let's work a little. I read the section again and found out that they use the one that maps infinity to C, to the cusp, so I did it the wrong way. On the other hand, this is okay, but I'll just do it following the text very verbatim. Next, this is a rabbit hole. I have 4 variables here and get 3 equations. So that's the wrong way about it. We know the... and another thing is that we also need to consider the possibility that these two are -1 and this vanish. But it's more easy to say we know the solution. We know that it's plus minus 1h naught 1. And then just do the opposite operation and see when it lies in the group, which of course is gamma naught of 4. I'll start with taking the cusp at naught and then following the book very verbatim to see what happens. And of course, naught is s operating at infinity. And what do they do? First they define psi, which is the element of G, one element of G, which contains S, and there are 4, of course. So there is a factor T, and then it's square root of minus Z. This is a little weird. Z lies in H, and that means that minus Z lies down here, which implies that the square root will lie in the 4th quadrant, and then multiplied by T. And we have to find the inverse. Or minus S. And then the inverse, that's 1 divided by this guy, but with this one operated on it. So it's t to minus first, and then 1 divided the square root of minus 1 divided by z. This guy lies in, no, it's minus 1 in h, so when we take square root we end the same place. Okay. So that means that all of this must give square root of minus z. Now that's weird. That's very weird. Is it possible? If we take I, then minus I It's down here, so it's minus 1 minus I divided by square root 2, and 1 divided by I, that's minus I, and the square root gives the same. And if we go close to the x-axis, to the real axis, then minus z is there, so we end here. Mind you, a point here will end up here, whereas 1 divided by z, that lies here. So the square root will be the same. That must be minus z. Shocking. All right. Next, we have g1 of infinity. Fixing infinity, that's the opposite way. G1 fixing infinity, of course, is plus minus point t, where j is an integer and t any of the numbers, any of the 4 numbers in capital T. And then gamma S mark, that is the members of gamma naught of level 4 fixing naught. They are alpha, G alpha minus first. Of course, those that actually lies in G1. Now in gamma naught of 4. So let's just do them. So let's do the matrices first. First we map 1 naught to infinity, then translate it, and then maps it back to naught, right? And that means we have to have 4 dividing j. So the generator is plus minus 1, 4, 1, naught. And of course this lies in gamma naught of 4, so we can actually find the value of the second part. Now what was that called? The generator? It's called psi. the symbol 4 on 1 gives unity. Epsilon d of 1 is unity, so it's just square root 4z minus plus 1. And the inverse there's 1 divided by this, where z must be operated on by this guy. Did we call that alpha? I think we did. There was a plus 1 missing here. So it's 4z minus 4z plus 1. And wouldn't that be very nice if that just was the square root of minus 4z plus 1? Minus 4z plus 1 lies in minus h. So 1 divided by lies in h. So the square root is up here. Now minus z lies down here. Oh, lies in down here. So the square root of that lies down here. Damn it. So that wasn't right. Well, it's probably 4z minus 1. If z like we had to change sign up here, so let's assume that pending later verification. Now, what am I doing? This is quite silly because this one lies in what is it called? In gamma naught of level 4-2. So that means we can just apply, find J of this matrix point Z. Minus 4 over 1 gives, so it's unity, and then the square root of minus 4Z plus 1. All right. That's a little weird here. Oh, we had to take the reciprocal, then we end down here. All right. So it agrees. And the next thing we needed to do was what? That was this element. It's of course yeah, what is that? Now what do we have to do? Yeah, then we have to map it. So I don't need this at all. Well, we have to map it back to be around naught. And we do that with S. I don't really dig this. This maps naught to naught, of course. So this maps naught to naught. But where does t come in? It comes from here. This map has t equals unity. Now let me write up something and let's see what it gives. Psi to minus first, and then the generator here, 1. I'm very confused. I have to take a break and make a cup of coffee and read the section once again. I'm sorry that it is so difficult for me to understand these things. I have looked at it again and found out that I went off rail here. So we'll just delete that. We already have psi up here, so that was not the right thing to call it. Let's call it phi. And then we have to compute psi, phi, psi inverse, and that should give I haven't written it anywhere. The matrix 1.4.0.1, and then our constant t. And of course t will cancel, so we can just use square root minus z. And I don't know what if it takes minus and then damn it, that was wrong. That was this guy where we already have the value being my god, square root 4z plus 1. And then the reciprocal of psi Of course, this should not give any sweat, because the matrix minus 1 and 1 here actually implies that that's a possibility. So we start from the left. I would so much like just to write square root of minus z. But let's work a little on it. This lies in h, so this square root is up here. And this is the same. So the product lies here. Square root minus z is down here. So it lies here. So we are actually, it not gives the same. I believe it's just changing sign, so let's assume that. This lies in h, so this below the real axis, so the square root is over here. And square root of minus z is over here as well, meaning the product lies here. And then we take a minus sign, so we end up here. Now, I would like, we can say, I forgot, did I take this minus into account or not? This is h, this is down here, this is here, minus z is down here, so they're both down here. So when we multiply, we end up here. And if z approaches 1, that's not a good choice. Let's take the imaginary unit. Minus I, the square root lies here, and 1 divided by minus I gives plus I, so it's still minus I, plus I, the square root lies here, so the product along the real axis, how could it give minus 1? Well, let's do C, and then I hopefully will have learned the lesson. So it's the cusp 1/2, and alpha is so first the matrix. 1 plus 2 gives 3. Are we far off? Well, well, well. I can't find the mistake, and it seems to be borne out by this one agreeing. So what have I done wrong? Well, if the matrix, could it be this that's wrong? No way. Could it? 1, naught, naught, 1, no. There seems to be a mistake here, though I can't find it. So, time for another break. I think I found the mistake. We have to multiply by psi. So there's a lot that needs to be changed here. Well, I don't know what we should call this. Gamma tilde. Oops. And then the inverse of psi. And let's see if I get a better feeling from this. 1 minus 1 and 2 plus 4, 6, minus 2 minus 3 minus 5. This looks very much like what I did. Z minus 1, no, not quite, divided by 4z minus 3. Let's believe we have sufficient room. That's not pretty. That's really not pretty. Times. And then in here, 2z. Oh, I forgot the plus 1. 2z plus 4z, that's 6z minus 2 minus 3. And let's assume again it's square root of 6z minus 5. And the reciprocal we have here. Here. And now, 1 plus 2, that's 3. We are still off. This is annoying. One minus 1. It must be minus 1 to have determinant 1. We should have minus 1 as far as I remember. So there's a sign wrong. Well, we kill it for today. Hello there, it's now Tuesday morning and I've finished the problem. You see my calculation here, the one that gives t. I've computed it, and actually I got some help from Mabel. This is not difficult to see. This lies in h, so this must be in minus h, so it's not difficult to see, but not to accumulate insecurities, I let Mabel do all the reductions here numerically, because I could of course make assumptions and then hope it could do it right, but I'd rather do it numerically. And also the matrices, just to make sure, I did that numerically. And then I wanted to check the different results to see what we got. And with t, we got minus the imaginary unit. With minus t, the imaginary unit. With the reciprocal of t, that makes sense. It's 1 divided by I. And this one, we got minus I as well. And when we write up the matrices, we can see that where we have the positive entry here, we get the right result. That means that my answer to the cusp 1/2 or minus 1/2, whatever you care to call it, is that h equals 1 and t equals minus I. And I've learned really to operate on, to perform the operations in the group G now. I feel comfortable that I can do that. So that was the result of that problem.